Hello, Year 12. Okay, so for today's homework, you've been asked to watch this video, make some notes, and at times I'll ask you to stop the video so you can have a go for yourself and then play it again to see what you've done and just to try and build your understanding really while you watch through. So the best way to watch this video is really going to be to pause on it as you go through, thinking about each part, making some notes, maybe drawing down some diagrams. You're going to see some graphs, you're going to see some triangles, and those are things that you're going to need to know for yourself for your exams. So a good idea to pause it as you go through and make some notes. So the first thing we're going to talk about is trig. This, what you can see in front of you, is really straightforward. This you've been doing since GCSE, just the trig ratios, sine, cos and tan, and how they link with the sides of a triangle. So sine theta opposite over hypotenuse, cos theta adjacent over hypotenuse, and tan theta opposite over adjacent. Obviously they are with a right angle triangle. So if this was theta, you've got your opposite, adjacent and hypotenuse. So for any triangle we'd be able to work out sine of theta using these different lengths of the different sides of the triangle. What we've got also, which you should know by now, are some special triangles that actually give us some exact values. So any triangle is going to give us an answer for sine of theta, but some triangles, two special triangles, give us exact values. So these are two special triangles. If you can't remember them, you can actually easily build them up using some basic skills like Pythagoras. If we look at the first one, all you need to remember that it's an isosceles triangle with sides 1 and 1. Using Pythagoras, you can then get the hypotenuse, which is going to be 1 squared plus 1 squared, 2. So that side is the square root 2. Because it's an isosceles triangle, it should have angles of 45 degrees. Because they need to be the same because the lengths are both 1. For the second triangle, you've got basically the easiest way to remember it is to start as if it was an equilateral triangle. So that angle is going to be 60 degrees. That one then has to be 30. And that would have been 2, so it's been cut down to a length of 1. The hypotenuse is a length of 2. We can use Pythagoras to do 2 squared minus 1 squared, square root of 3. So there's your two special triangles. The reason they're special is because using these we get some exact values for some common angles that we actually use quite a lot. So we can work out sine of 45 degrees, cos 45 degrees, and tan 45 degrees. And here we can do sine 60 degrees, cos 60 degrees, and tan 60 degrees, as well as sine 30 degrees, cos 30 degrees, and tan 30 degrees. So using these triangles, can you now please pause the video and work out what each of these would be as exact values without using a calculator? I'll just give you a second, pause the video, and then I'll come back. Okay, so the first one, sine 45, we've got opposite over hypotenuse, 1 over root 2. Cos 45, adjacent over hypotenuse, 1 over root 2. And tan 45, 1 over 1, which is just 1. From this one, sine of 60, root 3 over 2. Cos of 60 is 1 over 2. Tan of 60 is root 3. Sine of 30, 1 over 2. Cos of 30, root 3 over 2. And tan of 30 is 1 over root 3. If you compare the sine 60 and sine 30 with the cos 60 and cos 30, they're actually just switched around, so that's something to note just to help you remember those things. So what we've got so far is our special triangles with the angles, some exact values that we can find using our trig ratios. What we're actually moving on to today is looking at some other values. A lot of the time we've only worked with angles up to 180 degrees, basically working in different triangles and shapes. But actually, if you look at your calculator, if you put sine of 500 degrees in, you still get a value. If you put cos of 280 degrees in, you still get a value. So there are actually trigonomic values and answers greater than what we've really worked with from 0 to 180 degrees. And what we're going to do today is I'm going to show you some ways of how we can find those values. So, the first thing I'm going to show you is a graph, and it plots all the results from the sine ratios. from 0 degrees, let's write it right up, 0 degrees up to 180 degrees, and then actually back up to, further up to 360 degrees. And this sine graph, every value you get as an answer to sine will go between 0 and 1, or down to -1. So that is the basic shape of your sine graph. Just check it out. Any value less than 180, if I do sine of 160, it's about there, should get a value of 0.342. So that's a positive value, works fine. If we read across, that would be about there on the graph. Now we're not actually going to use these graphs to get exact values, it's just to help us to show where they would be, whether they're positive and whether they're negative. If we do sine of 200, the value we get, minus 0.342, it's going to be down here, which works. Right. The important thing we need to know about these graphs is that they're symmetrical. So if I do 160, which I've just done previously, you get sine 160, 0.342. If I do sine of 200, you'll get minus 0.342. Since 160 was 20 less than 180, and 200 is 20 more, it's a symmetrical value, just plus or minus. So that's something that's going to help us later on. The other important thing to mention is that actually these graphs don't stop between 0 and 360. This graph will actually continue on in the same cycle as it did before, and it goes into the negatives in the same way. So you could plot it out and it would continue on. Now what this is called is it's periodic, okay, and the period is 360 degrees. So from here up to here is one period because it's a full cycle and then it repeats itself. So it's periodic and the period is 360 degrees. Right, now why would we actually use this? Well, if I put in, let's say I have an answer, so sine of an answer of 6.4278, okay, 6.42, 0.642. If I do the inverse sine of that, I get 39.9. Okay, so that tells me that 0.642, which is about here, gets me an answer of 0.642. The inverse sine of that gets me an answer of 39.9 degrees. Right, now looking at that, what we would always have done in the past is think that, okay, there's only one answer, 39.9. But actually, if you think about this graph, there's also going to be another value here, which when you take the sine of it gets 0.642, which means that there is another angle that we need as our answer. So how we can find that out is using the symmetry of the graph. Well, this was 0 plus 39.9, so 180 subtract 39.9 should also give us an answer. 180 subtract 39.9, which is 140.1. That angle should also give us 0.642. So let's try it. Sine of that answer, 0.641. That's because we've rounded it a little bit. So actually, there's more than one value, more than one angle to get each result in sine. If you continue, this is only looking from 0 to 180. There's nothing from 180 to 360 because it's down here. But actually, if you went further than 360, we would be able to get another angle here. So it'd be 360 plus 39.9, 399.9, and so on. And we could repeat that. We could also go negative and go this way. And even though we haven't considered this before, but if that was minus 180, then this value here would be minus 180 minus another 39.9. So it would be minus 219.9 degrees. So we haven't considered negative values, but actually if you put in negative 219.9 degrees and take the sine of it, you should also get 0.642. So minus 219.9 sine of that 0.6414. So we get these values, and there's actually more than one, and that's the first time we've come across that. Anyway, this graph then, if you plot it out, will show you all the different values you can get within a given range. Okay, that's it for the sine graph then. So we can find lots of different values instead of just the one that gives us on our calculator, using this as a quick sketch. So, looking on the cost graph, now actually sine and cos are quite related and they're very similar. To get the cost graph, all you do is take the sine graph and translate it to the left. So if you look at this, starting at 0 degrees, it's going to be 90, 180, 270, 360. So the sine graph is a period of 360 degrees as well, and then it will also repeat itself as you went down. It will repeat itself negative as well. If I could draw it. And so on. So it's got a period of 360 degrees, but this time it actually starts at 0 degrees, it's at its maximum, which is 1. Cos of 0 is 1, as we know. And then cos of 180, which we've never really looked at before, cos 180 is minus 1. So this time you can do the exact same thing. If I did cos of 60 degrees, which is a half, so actually inverse cos of a half would give me in my calculator, inverse cos of a half gives me 60 degrees. Now that we can use the graph, we can look and find out actually there's going to be another value between 0 and 360 degrees. If you just pause the tape, you'll be able to figure out what that is, and then we'll do it in 1 second. Okay, so since it was a half, if we go along the graph to the next time the curve hits a half and read down, it should be somewhere here. And that's going to be, this was 90 take away 30 to get 60 degrees. So we're going to do 270 plus 30. 300 degrees should also give us that value. So cos of 300, and it also gives us a value of a half. Alright, so that's again using the cost graph in the exact same way. Right, just one question for you to have a go at then. Could you, using these two graphs, if you can get them to fit in, find all the values between 0 and 360 degrees of the following two questions. Sine, the inverse sine of minus 0.5, and the inverse cos of minus 0.5. So you can pause the tape and have a go at both of those. Okay, so in our calculator, if we type in the inverse sine of minus 0.5, we get an answer of minus 30. Well, minus 30 would be here. So it's there. So since I asked for the answers between 0 and 360, we can read along and find that there's going to be a value there and also another value here. Well, thinking about the symmetry, minus 30 was 30 left of where it met here. So it's going to also be 30 right of that. So it should be 180 plus 30 and 360 minus 30. It gives 210 degrees and 390 degrees. Or sorry, 330 degrees. You can check those in your calculator. Sine of 210 minus 0.5. Sine of 330 minus 0.5. Okay, using the cost graph then, cos of minus 0.5, inverse cos of minus 0.5, inverse cos of minus 0.5, is 120. So looking at that, 90 is going to be 120, so it's here. And we're going to read across, and it's going to be actually down here. So that's the value, minus 0.5, gives us 120. But that's not the only answer, because if we keep reading across, there's another value here. Using the symmetry, it was 90 plus 30 to get to 120, so we can do 270 minus 30, which is 240 degrees. So 120 degrees and 240 degrees are two answers for cos, for the inverse cos of minus 0.5. So the whole idea here is that we can do different values, and we do not just get one answer like our calculator would give us. We can find out lots of different values. Okay, that's that for the graphs. The final one I'm going to show you is the tan graph, which is actually very different, but you can use it in the exact same way. So the tan graph is also periodic. Goes 0, 90 degrees, 180, 270 and 360. So, and again, you can go to minus 90 and continue it, or you could continue it on past if you like. But what the only difference here is actually, and you know this already, that if you do tan of 90 degrees, there's a math error. That's because there is no value for the tan of 90 degrees. If we quickly look at why that is, if theta was 90 degrees, we wouldn't have an opposite and an adjacent, because that would not actually make a triangle. So it's impossible to get a value where theta is 90 degrees and use the tan of it. So using this as a quick question, we could give, let's try and find the tan to the minus 1, the inverse tan of 10. Okay, so inverse tan of 10, that gives us 84.28. It's quite close to that. So 10 goes along here, 84.28. Let's do it in different colours so you can see clearly. 84.28. Okay, done. We could read along, continue. Let's do the inverse tan of 45. Or the inverse tan of 0.5. We get values for those. Lots of different values. So looking at, if the question then said, well, find all the values for the inverse tan of 10 between 0 and 360 degrees, could you now just try and work out what those would be? And just pause it for a second. Okay, well, the calculator gives us our first one, that's 84.289. 289 degrees, so 84.289 degrees. Using our graph, if we read along, there's going to be another one just before 270 degrees. Well, 90 minus 84.289 gives us 5.71. So we need to do 270 minus 5.71, which gives us 264.3 degrees. So there's two angles between 0 and 360. There's another one here, but it's actually past 360 degrees, so we didn't have to worry about it for this question. Right. So, as a summary, what you need to do is to be able to sketch the tan graph, asymptote at 90 and also 270. You need to be able to sketch the cos graph, which starts at 1, goes down to minus 1 at 180, then back up to 1 again at 360. And sketch the sine graph, which starts at 0, goes up to 1 at 90 degrees, back down to 0 at 180, down to minus 1 at 270 degrees, back up to 0 at 360 degrees. And then they just repeat themselves. You also need to know your special triangles, and you also need to be able to find the other values apart from what your calculator gives you when you're doing inverse cos and things like that. Alright, thanks, and see you on Thursday.